Hi Debbie, I'm just quickly going to canter through the various examples that you have sent me of perspective. I can see that you've grasped it nicely from this cheese wedge example you've sent me with the Rubik's Cube. And in your explanation, you've hit on the nubbly point that everyone discovers sooner rather than later, which is that most complex real-world objects are a mixture of both of many kinds of perspectives. So a lot of them, depending on where your eye level is, may be a mixture of bird's eye and eye level. So for example, say if you are looking at a dining room chair, but you were sitting quite low down, so you were sitting on a couch, you might see the top of the chair, the seat, but you'd be looking up at the back of the chair. So it would be a combination of eye level and bird's eye. Similarly, especially with a house, there are parts of it which will tower over you, and there are parts like the floor that you'll be looking down at. So again, you got this kind of mixture. So I'm just going to go through and have a look at this. Let me just move this up. I'm just going to make it a little bit smaller and pop it in the corner. So a good thing to do to just test your knowledge or your understanding is to go and do this Rubik's Cube from the different perspectives. So here we've got, this is the horizon line, as you know, and that horizon line is the height of our eye. That is where we are looking at the object from. So if we go and say, okay, well, let's put our horizon line halfway down the object. So this is going to be where my eye is looking at. You can see straight away I'm about to do a kite. So here, let's go and say, this is the closest corner of my Rubik's Cube. Actually, let me just change to a different color so that we don't get muddled up. So that's our horizon line in blue, so it'll recede a little bit. Here is our closest corner of our Rubik's Cube. And then we're going to join it left and right to our vanishing points. Okay, so that gives us this sort of framework that we're working in. And then we decide where is the furthest away side of it at the front, and we make sure that that is vertical. And then we decide where the back side is going to be. Oops, why did it go much bigger? I don't know. But let's just do this. And put it in like that. Okay, so there's the front and side of our Rubik's Cube, and you can see that I'm kind of, let's call me, I don't know, bumblebee sized, standing beside the Rubik's Cube. And so I'm looking up at the top of it. I can't see the top surface, and I can't see the underneath, obviously, because I'm standing next to it. But we would end up with our thirds of the cube like this and like this. The closest one would seem slightly bigger because we're closest to it, the width of that, I mean. And then the further away ones, take that and that. And then if we go with our thirds like this, I'm not being very precise here, but it's as good as it's going to get right now. Okay, and then that would give us our Rubik's Cube. And if I had been clever, I would have put the blue in a different layer so that we don't have to deal with it here. Okay, so if I just quickly erase that, you can see that this is now a kite's eye view, so as if we are sort of eye level with the middle of the middle line of the cube. Okay, if we wanted to do it from a worm's eye perspective, what we would do is this. So imagine that our worm's eye means that we're looking up at everything. So it's the opposite of bird's eye. Horizon line, or point of view of the eye, is right down at the bottom, and then the entire object is above the horizon. Okay, so then we would just join here and here, and we would be looking up at our Rubik's Cube. So this is quite literally the opposite of that. And if we were looking from underneath, say it was suspended in mid-air, then we could actually end it further up. So we could say, let's just say this is the closest corner and say it is dangling in mid-air. Then we've got this situation. So where we go like this and like this, joining to the horizon line, the vanishing points on each side. Like that and like that. And then the front face like this and the back like this. And obviously we have to join away like this to make it show us the underneath. Okay, so that then gives us the what I call the worm's eye view of the Rubik's Cube. So then you can see like that, very roughly, how you could be looking up at a suspended Rubik's Cube. And if it was on ground level with you and you were looking up at the whole thing, you would take this line all the way down to the horizon line. So it's a good idea to just test your understanding by doing that, making sure that you can construct the Rubik's Cube so that you could either see the top surface, knowing that you're looking at it from a bird's eye perspective. This one where you can see neither the bottom facet nor the top facet, you can just see these two sides, and you know that because you can see two sides, it's definitely 2 point. And here we can again see three sides, but we can see the underside and side 1, side 2. That is worm's eye. If we can only see two sides, but the bottom is flat, then we know that we are either on ground level with it, and it's going in two different directions away from us like this. So if the bottom is flat, but we can see two sides, we know that we're looking at some kind of 2 point perspective, but just on a level with everything. Okay, so that is that. Let us move on to your next example.